Hello friends, this is Sushrut Tendulkar and welcome to my YouTube channel. This is the fifth video in the series Introduction to Natural Language Processing. In this tutorial, we're going to learn the simple architecture of recurrent neural networks or RNNs. We'll then look into the RNN language models, and finally we'll look into the advantages and disadvantages of RNNs. Let's get started. Types of language modeling. In the earlier tutorial, we had seen two types of language models, and we had also seen the statistical language models, specifically the N-gram. In this tutorial, we will focus more on the neural language models. Intro to RNNs. We have also seen simple neural architecture in the previous tutorial. If you observe this, there is a simple neuron which would take two inputs, multiplies that with two weights, adds a bias, and then finally passes through an activation function to produce an output. This neuron is then extended to create a simple architecture that would produce the output. Now let's modify this neural network slightly. So the same neuron with two inputs, two weights and one bias. Let's add two more inputs to this, two more weights. So that makes it 4 biases and one output. Let's add 4 more inputs. Let's call H inputs. We'll add 4 more H input weights. You add all of them to produce 4 outputs. So what we are doing here is we're storing the output of this neuron in the same variable as H inputs. So there is an idea behind that, which we'll cover in a second. So if you look at this neuron, there are 4 numbers, 4 inputs multiplied with 4 weights plus 4 biases should give us the 4 numbers or the output with 4 values. We can modify this neural network a bit, and with that we'll construct a simple architecture of that neuron. So we have inputs x1, x2, x3, x4, hidden inputs h1, h2, h3, h4, which would give us the output again h1, h2, h3, h4. Now let's add one more neuron to this new set of inputs x5, x6, x7, x8, which would produce again the hidden state h1, h2, h3, h4. Similarly, we can add one more set of inputs that would produce the output again as h1, h2, h3, h4. So if you notice here, the weights which gets multiplied to the inputs are common across the neurons. We call it as WE. Similarly, the weights that get multiplied to the hidden inputs h1, h2, h3, h4, they're also common. So we call them WH. What's different is the inputs. For each neuron, the input is different. So that's the key differentiator here. If we feed in the actual numbers, this is how it would look like. The weights, as I said, are same across the neurons. The initial inputs h1, h2, h3, h4 are randomly assigned, and after that it depends on the inputs whatever we give in the form of x1, x2, x3, x4, etc. So what are these inputs? This input can be the one-hot vectors for the words we are analyzing. If we look into a simple Python code for this, so we define a class called myRNN. In the init function, we initialize the different weights WH, WE, WY, and biases B and BY. As you said, WH is the weight that gets multiplied to the hidden input. WE gets multiplied to the different inputs that we feed in. In the forward function, the hidden state values are initialized to be 0. The important part of the neuron is these two lines of code. The architecture what we saw here can be represented using these two lines of code. So what's happening here? We're taking the inputs, multiplying with the weights, then adding the biases and storing it in the same variable h. We have a for loop that will perform this operation multiple times depending on the number of inputs, passes it through an activation function, so we are using tan h here, and then stores it in the same variable h. And finally, we compute the output based on the softmax function, which we're going to cover in a second. Architecture of RNN. So there are different ways in which we can represent a recurrent neural network. So the whole idea would remain the same. There would be an activation function A, or the cell, that takes the input xt at different time steps, produces the output ht, and feeds the same output ht to the same activation function. So we can expand that to visualize it better. What is the core idea of the recurrent neural network? So it's nothing but applying same weights W repeatedly at different time steps. So why we are doing this is, the weights is something that we would be interested in for different inputs at different time steps. So this weight should be able to learn the meaning of the sentence which we are feeding in. Let's see how an RNN language model would look like. Let's say we have a sentence, thanks for your. Let's call thanks as x of 1. So we can represent this as word vectors or one-hot vectors. We can feed this into an word embedding layer. Let's call the output as e of 1. Pass it to a neuron with the weights wh and we. For the initial state, we would need random weights. Let's call h0, and this would produce the output h1. And this is how we would perform the operations inside the neuron, which we have already discussed. Hidden states get multiplied by wh, the input gets multiplied by we, and then the bias is b. So at the next time step, we have a new word for. We call it x2. We'll perform the same operation, which will produce the output h2. Similarly, for the next time step, we have the word your, and that will produce the output h3. Now this h3 is the probability distribution of the words in the vocabulary. The words with the highest probability is most likely the next possible words. And this is the whole purpose of the language model, which is to predict the next best word in the sentence. What are the advantages of RNN? It can process any length input. So n-grams couldn't process the sentences which were very long, or the limit was dependent on the type of n-gram we choose. But RNN can process sentences of any length. Calculations for any given time step t can use information from many time step back. N-gram language models couldn't do that because they could remember only 4 words. Say for example, if the n-gram was 4 gram. The model size, the weight parameters, is not dependent on the length of input. Even if we increase the number of words in the sentences, we don't have to change the weight parameters. What are the disadvantages of RNN? The main disadvantage in practice is it is difficult to access the information many steps back. Even though in theory RNN should be able to access the information many steps back, the main challenge here is called gradient descent. As we move along the sentence, the information from the initial part of the sentence would get lost. A final note on RNN. RNN is not a language model, but RNN can be used in language modeling tasks. RNN can be used for a lot of other tasks as well. Finally, why language modeling? Language modeling is subcomponent of many NLP tasks involving generating text or estimating probability of text. Some of the applications of language modeling can be in machine translation, text summarization, speech recognition, spelling correction, etc. So language model acts as a base for all of these tasks. So that's why language modeling is important. Let's recap what we learned. We saw architecture of RNN. We saw RNN language model and advantages and disadvantages of RNNs, and why language model is important. The important part of any neural network is training, and training the RNN and backpropagation is not covered in this tutorial. which we will cover in future tutorials. Well, that's it for this tutorial. Thank you so much for watching. Keep learning. Bye bye.